Now, personally, I like graphing and elimination the best. I rarely use substitution unless they tell me I have to. Substitution is only really useful when one of the variables is isolated or solved for already. So if they're both in standard form, you don't want to use substitution. But if, for example, and we'll see one right below, if I gave you y equals 2x and 7x minus y equals 15, which this is example 2 on our paper, this would be an example of maybe where you want to use substitution. Again, what you'll do is, since this variable is solved by itself, what y is equal to, we can substitute that in for y. That's what substitution is. So it works really well if one of the two equations is solved for a single variable. Elimination is most useful when they're both in standard form. Oops. And that's where we get our coefficients to max, and we actually eliminate one of the variables by adding or subtracting the equations, make them go to 0. All right, so here's our steps for solving by substitution. First of all, you want to solve an equation for a single variable. You'll substitute like I showed. You'll solve the equation to get the value of either x or y, and then you'll plug it back in to find the others. Make sure that you don't forget to write your final answer as an ordered pair, and also make sure you don't put it in the wrong order. It has to be x, comma, y. Now, example 1, personally, since these are both in slope-intercept form, some of you would probably prefer to graph them, but the directions say to solve using substitution. So again, since y is equal to negative 4x plus 8, I can substitute this in for y in the second equation. So basically, you're getting rid of this and replacing it with this. And then we are going to solve for x. So I would probably add 4x to both sides. Subtract 7, so we are going to get not a whole number as our answer, but that's okay. So 8 minus 7 is 1. 1 equals 5x. Divide both sides by 5. Make sure you don't think your answer is 5. It is 1/5. Or 0.2. 2 tenths. 1/5. 2 tenths. 0.2. Now we need to take that and plug it back in. Again, I might go ahead and use the 0.2 just because it'll be really easy. And you can plug into either equation. It does not matter. You don't have to plug into both. I would pick the one that looks easier. So equation 2 looks really easy. 0.2 plus 7 is just 7.2. So now I'm going to take these two things and I'm going to write them as an ordered pair. So that would be 0.2, comma, 7.2. Now let's suppose your answer ended up being 1/3. You would not be able to round it and make it 0.3, since 1/3 is 0.3 repeating. You'd want to leave it as a fraction 1/3. But since this is a terminating decimal, you're more than welcome to write it out. Okay. In number 2, one of our variables is already solved for, y equals 2x. So I can use the substitution property to take 2x and substitute it in for y in the second equation. So this will become 7x minus 2x equals 15. Which, those of you that are in geometry, you can use this process when there's two variables in the vertical angle problems too. This can help you. You don't have to do it, but you can. And then combine your like terms on the left. 7 minus 2 is 5. Divide and we get x is 3. Plug 3 back into one of the two equations to find out what y is. I'd do equation 1. We'll get 2 times 3, which is 6. So my ordered pair is 3, 6. Now again, if you want to check your answers at the very end, you can take 6 and plug it in for y, 3 and plug it in for x in both equations and test to make sure that it works. So if you had time on a quiz or test. Now if you remember back in Algebra 1, they probably said solve using substitution with equations like this. I'm not even going to make us practice those because if they're in standard form, you should choose elimination. It's the fastest, it's the easiest. Why waste your time doing substitution? The only time I would suggest doing substitution is, again, when one of the variables is already solved, for y or for x. So when we solve by elimination, we are going to make sure the equations are in standard form, make sure the x's are stacked on top of each other, the y's, the equal sign, and the numbers. Then you're going to determine which variable to eliminate. Okay, to eliminate a variable, they have to have matching coefficients. Now, if you do matching coefficients, but you have them with opposite signs, so one's a positive 3, one's a negative 3, that's going to make your problem a lot easier, because then you would have to just add the equations. Sometimes when students subtract the equations, they forget to distribute a negative, and they make a mistake. So my suggestion is to get matching coefficients with different signs. Let's say with opposite signs. If you do it that way, you will always be adding, and you'll be less likely to make a mistake. Now, if you don't like that, and you remember your teacher last year allowing you to add or subtract, you can do it. I don't care. But I'm telling you, if you do it this way, you're less likely to make a small little calculation mistake. Of course, once we get the value of one variable, we'll plug it back in to get the other. So looking at number 1, we can compare our coefficients. We have 2x and 6x. Those aren't the same. We have 2y and negative or minus 2y. So these ones are matching coefficients with opposite signs. So I am going to eliminate the y variable. I don't even have to multiply. Sometimes we'll have to multiply to get them to match. These already match. So when they're different signs, you are going to add the two equations just downward. So put kind of a big addition bar underneath. 2 plus 6 gets me 8x. Double check, 2 plus negative 2 would be 0. I'm not going to write it down, but it's really 0y. Bring your equal sign straight down, and 10 plus 14 is 24. Solve for x, divide both sides by 8. We get x is 3. Now I want to plug 3 back in. Again, it doesn't matter which equation. I'm just going to do the top one. And then you'll perform inverse operations to solve this. So 2 times 3, first of all, is 6. Then subtract 6. And divide by 2. Make sure you take your two answers and put them as an ordered pair, because the solution is where they intersect. And if you have time on a quiz or test, then check it, plugging it into both. All right, now the next one, looking at our variables, the 4's match, right? But they're different. They're the same sign. They're both positive. So if you don't want to change the sign of these, you would subtract, and you just have to be careful that you would go out and subtract each thing. My suggestion is to multiply by -1 in either the top or the bottom one. It doesn't matter. That way they'll have different signs. So this would become -4x. -1 times a -2 would become a plus 2y. And a -1 times a -2 will become a positive 2. The reason I suggest doing this is that then all you have to do is add the two equations. When they have different signs, we will always add downward. So 4 plus -4 is 0x. Y plus 2y is 3y. 7 plus 2 is 9. We divide and get 3. Now again, had you have not done that up here, but you don't have to, you could have just subtracted the equations. 4 minus 4 is 0, but you have to be careful. It would be 1y minus a -2y, which turns into a positive. Some people forget to go out to the minus, and they would say 1 minus 2 is -1. So that's the mistake I see all the time. That's why I suggest making them be the same coefficient with opposite signs. All right, once we do this, again, if you were to get this answer wrong, then your next answer is going to be wrong too. So you just want to take your time, plug it back in. 4x plus 3 equals 7. This one I'm plugging it in for y, not for x. And I'll get x equals 1. Again, make sure you write it as 1 comma 3, not 3 comma 1, x then y. So these ones were easy because they already had matching coefficients. The next few are not going to have matching coefficients, so you have to make them become matching. And there's more than one way to do it. So some students will say, oh, I'm going to make these both into 6s. I'm going to multiply this one by 3 and this one by 2. Other of you would notice that I could just multiply this one by 2 to make it match. That's what I would do. I like to do the least amount of work. So I would multiply the second equation by 2. That way my y's will match, and they're going to have different signs, so that's going to be good. Now when you do this, you do have to distribute the 2 all the way over to the 5 as well. So make sure that you do all 3 parts. So we'll get 6x minus 2y equals 10. And then the top equation I'm just going to copy right over. You could also copy it underneath if you wanted to. It doesn't matter what order you write them in. Again, I'm eliminating the y variable. 2 plus negative 2 is going to be 0. So I am adding these. 2x plus 6x is 8x. These go to 0. 6 plus 10 is 16. And we divide to get x is 2. Is this coming back to us from Algebra 1? And then we'll take 2 and we'll plug it back into for x in one of the 2 equations. And we'll solve. So we'll multiply first, then subtract and divide. Last but not least, throw those together as an ordered pair, 2, 1. Ashley?
If we were to plug x back in for the second equation, would we keep the original thing? What would you times it by 2?
I would do the original, yeah. You can do the other one because if you multiplied it by the same constant, it should stay the same. But I would plug it into the original. But technically it doesn't matter. All right, example 4. Why don't you guys try this one on your own? And then we'll take a look at ones that may need to multiply more than one equation by a number. And of course, a word problem. Yeah. I would probably do -4. That way the signs are different. And you can add, but you can do 4 and then subtract the equation. Decided to multiply the top equation by a -4. That way I got matching coefficients with different signs. Most of you got the correct answer, which is 3, 1. Yes. But I did see one of you with the wrong answer, and I think that the mistake is that you got a -1 as your y, and then when you plug -1 back in, it gets you the wrong final solution. So just be really careful. If you left it as just a +4, you did have to subtract the equations, and just be careful that it would have been minus 16 instead of plus 16. So just be careful there. It was 16 minus a -3, so this should get us a +1. And then whenever we plug it back in, again, we got x is 3. So one small little negative mistake can mess up your first answer, which messes up the second answer. So again, my suggestion if you are making mistakes is to make sure that they're different signs. That way you're always adding, because adding is easier than subtracting 2 equations. The last 2 that we have then have the problem of I can't multiply 3 by something to get 4 or 4 by something to get 3 unless I want to do a fraction, and I wouldn't suggest that because then you're going to have to add fractions with a common denominator and all that kind of stuff. So in this case, you're going to actually multiply the top and bottom equation by two different numbers to get them to match. And you get to choose. If you want to make these become 12, you can. I would probably do the y's personally, because then they're going to be opposite signs and I'll already be adding. So it's up to you, but I'm going to make this become a 12, so I'll multiply the top equation by 3. And I'll make this become a 12, so I'll multiply the bottom equation by 4. But you could do it in the reverse order. Doesn't matter, it's up to you. Just make sure you multiply every single term by 3. Do the same thing in the bottom. And then we are eliminating the y variables, which do have different signs, so we are going to add them. So 9 plus 16 is 25x. 12 plus negative 12 is 0. Negative 3 plus 28 is 25. Divide by 25. We'll get x is 1. Plug x back in. Again, I would choose one of the original equations. It doesn't matter which one, but should get negative 1 for y. So the ordered pair would be 1, negative 1. See if you guys can try 6, and then also see if you could set up an equation for a system of equations for the word problem, if you finish that. For number 6, we should be getting negative 1, negative 1. And just be careful if you can do it differently than me. You could make these become 6s. I just made these become 6s, so I only had to multiply one of the two equations. But just be really careful. I remember in years past some students somehow losing a negative somewhere and having 1, and if you get this to be positive 1, then obviously you get the wrong answer, the y part. Again, adding the equations will eliminate a lot of your mistakes if you do that. The last one was a word problem. You should have had a chance to read through it at this point. They did define variables for us. So X is the number of packages of gift wrap that you're going to sell. Y is the number of packages of greeting cards. And it told us that we are selling gift wrap for $4 per pack. Greeting cards are $10 per pack. And they tell us that our class is selling 205 packages in all. So who can give me one equation they wrote? Ashley? Close. Gift wrap is $4 per pack, and gift wrap is X. So that should be 4X plus 10Y. Unless you define it equal. And what did you set that equal to?
4,000.
Perfect. I actually didn't highlight that part. Now, the way that you can set these up correctly is that anything that has a dollar sign, and a dollar sign, those are all going to go in the same equation. So $4 X plus $10 Y equals $1,084. Now the second equation is the one that students struggle to write. How would I express the 205 packages? Sam?
X plus Y equals 205.
Perfect. A lot of times they'll tell you how many total tickets you sold, how many total packages. That's always the number of gift plus the number of greeting cards has to equal the total, so X plus Y. And then you can solve this however you like. I think when I did it, I multiplied the bottom one by a -4. Again, I chose a -4, that way they'll have different symbols. You can also do a +4, but you would then subtract the equations. See if you guys can finish out that example if you haven't already. And at the end of the word problem, you actually will, instead of ordered pairs, you'll write the number of greeting cards and gift wrap.